Test, test, test. Ah, now my audio is working. I'll have to go back and edit this later. I just realized my microphone was messed up until now. So that's a bummer. Okay. Yeah, always check my mic first. That's a mistake. Um, okay. So when we left off this morning, um, we were taking a single secret hex and a hex string, and we were XORing over, XOR ciphering over that. And but I needed to be able to take a string value and convert it to binary. So I had from string to binary, but then I needed to get it back into string so I could see, for some of my test purposes, see if I could recreate like the word hello after I converted it to binary. So I added that function this morning, and it's real simple. It just takes the array of binary um, numbers, maps over those, and finds the decimal number for each of those. So we just do a little bit of math. We just implement this so we take the first number. Yeah, take the first number in the binary array, or on the binary, or yeah. So like, let's say it's like 1001, right? We take the first one, and then we iterate over the rest of the ones and zeros, and we multiply our accumulator by 2 and add the current step, and that builds us um, that converts the binary number to a decimal number, or to a base 10 number. So we did that. And then once we have a base 10 number, if you in DataWeave just do as binary as string, it spits it out as a character, right? As a string. So like, well, we can just see. So I can just show you what that looks like. So yeah, I have like 90 as binary as string gives you the letter Z, and 1 as binary. Well, let's do 57. 57 as binary as string is the number 9, right? Um, and uh, 75 is K, which means 76 is going to be L, and 77 is going to be M, etc., etc. 79 is O, 70 is F, right? So, like 86 V, right? So we're taking the basically it's a ASCII coding, right? We're taking the number, the decimal number, taking that, converting that to, and letting DataWeave do the hard work for us of getting that back into a string value. So, so that works. I have a working test suite for that. So I went over here in my binaries, and I took a, let's see, where's my test? So I had this test before from string to binary. It takes the string man and then \n and reconverts it to these binaries. So then I'm just doing it in the other direction. So it should convert a binary array to a string. So I take this, run my from binary to string, and I get back the string value man. And this test passes. So now we're set up to be able to take, to test whether or not we can do evaluations on whether or not our stuff is, our hex string here is what we want it to be. Because what we'll do is we'll take the hex, convert it to binary, XOR cipher it, and then we'll convert that to a string and see if our cipher gives us something that looks like English, right? So, and I think we have tests that are doing that already. So if I go to my XOR tests here, yeah, so if I do XOR encrypted hello, so XOR encrypted hello, fixed XOR, actually let's rewrite this to not use 2hex anymore. So if we do XOR encrypted hello, so do from string to binary hello, right? And then we'll do a fixed XOR. We'll zip that and do a fixed XOR of this. So what's from string to binary hello is going to be so from string to binary. Let's just rewrite this. Okay. So XOR encrypted hello is from string to binary hello, right? And we're going to import that from binaries. From binaries. And then XOR encrypted hello becomes, should become this, right? No, we got to zip it. So, or join it. So, XOR encrypted hello joined by that, right? Does that work? So if we have equal to XOR encrypted hello, it's going to return this. All right, actually, we'll do from string to binary and then from binary to hex, right? So we'll convert it to hex. So from binary. Do we have a from binary to hex? We may need to write that function. From, yeah, from binary to hex. Here we go. From binary to hex, that. We need to import that to hex. And that takes as an argument an array of strings, which is good because that's what this returns, right? From string to binary returns an array of strings. So we have from binary to hex, XOR encrypted hello. So we need to XOR encrypt that, right? So fixed XOR this, and it's going to be A. So from binary to string, from string to binary returns. Let's go look at our tests. I'm going to use our tests to tell us what we get. So from binary to string, or from string to binary, man returns this. So what does, when we're trying to test, from, we'll just keep it in the same, because it's another test for this, right? We want to see what this returns. So it should convert hello to binary numbers and do from string to binary hello must equal to, we'll give it an array. We'll just make it an empty array and run our test, right? You may have to go, no, that's fine. Run our test. Yep, there's our failing test. That returns, array size was 0 to be 0, but was 5. Okay, so we need to actually spit out the array. So let's just lock it right here, right? And what we're going to get is hello converted to binary. And then we're going to take that binary and convert it to hex. And then that gives us what we need to, and then we're gonna XOR encode that. So here is our array of binaries. Perfect. We'll just grab that. HELLO. Perfect. We will stick this in our test. Clean up our test. Oop. Boop. It's only good if you do sound effects when you do that. Boop. 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 And last but not least, let's go this way first. And just do that on the end. Okay, so now we have a test that tells us what we want here. We can take the log off now. Oops. Let's just do this. And take this log off. Good. Okay. So now we have our binary of hello, right? And so now we want to write a test that takes this hello and converts that to hex, right? So from binary to hex. Yep. So is that going to get handled elegantly? We'll do that here. So from it should convert binary from hello into hex in do comment. Let's see. From binary to hex, this must equal to, and we'll just do that. That's going to be wrong, but that's okay. We'll find out what the answer is here by writing our tests. We already have working code, so we can take the working code to figure out test scenarios, right? Yep. Okay, that actually looks right. A6865C6C6F. I think that's correct. So, yep, that seems right. So, from hello. Okay. All right. So, great. Okay, so there's our hex for hello. I think that actually might be what dataweave gives us if we do. So, let's actually just do this. Import star from binaries. And then if we do 2 hex, hello. Hey, look at that. We got a working, good. Okay, so that's perfect. We've got that. We're converting it to hex. Awesome. So, should convert binary from hello string into hex. Okay, so from binary to hex, let's go back up to here. So we have from binary to hex, from string to binary, hello, and then we're going to fix XOR over that, and that needs to be this many characters. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? 1, 2, 3, 4, 6, 7, 8, 9, 10, perfect. Okay. So we have our hex key. We're going to do a fixed XOR over the hex of hello. And that should, so we have XOR encrypted hello, right? So now if we have XOR, I think look, we already had 685. Perfect. Yep. Must equal to XOR encrypted hello. XOR decrypt string A. So, ooh, this might actually just work now. So we already had this from earlier. So we got rid of using to hex and from hex from data weave, right? We switched over to using our own functions that we wrote that handle it for us. So hello, but was this. Okay, yeah, okay, of course. So XOR encrypted hello, XOR decrypt string A. So we have a XOR encrypted hello, an A, and then if we wrap this to be from hex to, no, actually, let's do this. XOR encrypted hello from hex to binary this, and then give us back hello when we from hex the from hex to binary, and then let's look at our test here. So we have from binary to hex, from hex to binary, from string to binary, from binary to string. So we need from binary to string. So we have, yep, we're going to call that. So from, so this gives us, so from binary to string. So it gives us back, so we need to import that from binary to string. And we need to not do this here. We need to do this in our code. This is too messy. So we have XOR decrypt string, and we want to get back, so this should be XOR decrypt hex string, right? Hex string. Let's change that. XOR decrypt hex string. And then we're going to do a normal function for XOR decrypt string. So fun XOR decrypt string. And this is going to be string candidate string string, right, equals. So in this case, we take a string, convert it to, so should we, so I guess the question becomes, should we we could just do this. So let's go to our test from binary to string. break XOR decrypt hex string. Yeah, here we go. So let's break this test up. Let's make this cleaner so we can actually read it. So we're going to have a do and a var in here. Do var let's leave this for now so I can see what I had. Do var XOR decrypted binary equals from, and then we just grab all of this right here. Yep. Okay. And then we do dash, 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 and can we do this? Can we say from binary to string, XOR decrypted binary must equal to hello, and then we just delete this. Does that work? I guess the question is, can we do a do block inside of our XOR decrypt hex string? There we go. Okay, so we're going and encrypting hello, and then we're XOR decrypting hello and converting it back to hello. Yep. This should work. I'm going to be irritated if it doesn't. Uh-oh. It's a big empty string. X value to be hello, but was a big freaking string. Okay. So from binary to string. So let's log this. Well, no, we know what it is. No, we don't. Yeah, let's log that and see what we got. I guess I could have put the logger up here. Okay, so we got back a binary. Yep, XOR decrypted binary. From binary to string. So we've got back a binary, right? That's good. XOR decrypted binary. From binary to string, XOR decrypted binary. So this takes an array. So do this, right? Let's just set this as my payload. Right? And grab my from binary to string function. From binary. We just need these two right here. Right? C. Do that. We don't need any of this anymore. Okay. If we do from binary to string payload. Ah! Ah, interesting. So that's why we're getting a bunch of spaces because it's not oh, it's not characters that I care about, right? Oh, oh, it's chunk. So what happens if we encrypt it? Well, oh, okay, 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 cool. So yeah, it's working. It's just returning these hex characters that are yeah. So from binary to string, it's returning. So let's look at what from binary to string does one more time. So from binary to string, it does decimal math. Oh, yeah, it does decimal math and converts those to the corresponding characters. And in this case, they're they're like code characters, right? So what happens if we do that with a different set of if we do it with a different key? So can we use like FF? So FF. Let's just do 1 1 1 1 1 1 1. That's 10, right? 1 2 3 4 5 6 7 10. Yeah. And then if we do this with 10, 1, this with 1, right? Let's try that. It's actually going to be a different XOR decrypted string, I think. No, it's not. It'll still be the same. Okay, so something is definitely wrong. H E. Okay, so from binary to string. So XOR decrypted binary. So I messed up somewhere. So let's put this back. Let's put these back to A because it should have worked. Okay. So we did something wrong here. So let's do this. So we have interesting. So what? So this is this, right? XOR. So XOR decrypt hex string is XOR encrypted hello A, right? So hello A. So we're taking XOR encrypted. So we're just running it back the other direction, right? Running it back in the other direction. We should get back. Okay, so it gives us back hello. Okay, so what is just this? This is a hex string. So I have this. I can look at what this is. So 0 1 1 0 0 1 1 0 0 1 1 0 is 6. Okay. 6. So 6. 1000 is 8. It should come back as, yeah, it's going to be this. It's going to be this, right? 6, 8, blah, blah, blah. Yeah. 6, 8, blah, blah, blah. From binary to so. Yeah. Okay. So that's great. So if I just do this, so it's going to come back as this. So if I do from hex that, it's going to give me back hello, right? Good. Okay. So if I just do this, just as a sanity check, I'll say from hex that. We'll run this test and see if that works. And if it does, then there's something wrong with, oh, mm-hmm. Yeah, no, it's not here. It should be, um, that, right? So from hex that, and then this just should be XOR decrypted binary must equal hello. So if we run that, that's going to pass, right? Yep. So then there was something wrong with converting this back to string. What was this? Base 64. Oh yeah, so we do as binary as a string. Run that. Does that do it? Yeah. Yeah. So hello. Let me get back. Okay, so from binary. Okay, so then, so this is right. This up to here is right. So we need to take this, right? That, and say from hex to binary, right? And then that should be an array of numbers, right? Yep, it's 10. It's going to be these. So 1, 2, 3, 4, 6, 7, 10. Yeah, 10 binary numbers. And then if we do from binary to string this, and we say it needs to equal to hello. Why won't that work? And let me go look at my test for binaries. So from binary to string. So we've got these. Oh. Yeah. So I think the issue is with the size of these. We got to do some padding because these are going to be, so we have little short ones, right? We need to left pad those. We need to zip them and then convert them. So if we gotta do some conversion here. So from binary to string. So we've got this var format binary formatted binary equals XOR decrypted binary join by that, and then we're gonna split. We need to take we need to substring it. What's the best way to do that? Is there a way to get string? Do I have a function for that? So from binary to string. So I need to get this binary in this format. From binary to hex, from base 64 to binary, from hex to binary. So let's go look at my actual code here. So hex to binary table. So hexes are 4 characters. Base 64s are these characters. And yeah, okay, so I got to get hex back to um so we got to figure out, okay, so we have this from string to binary 8-bit padding, but the problem here is I need to do some bit padding here too, right? So my 8-bit padding there, so I have it from hex to binary. It's going to return a map of characters, right? So let's go look at my test for that. So from hex to binary, it's going to return these, right? Okay. So then we're going to zip that and go from hex to string. We're going to write a from hex to string function. And to do from hex to string, we have to convert this to binary, zip it up, and then we got to figure out what the conversion is. I think it's going to be 8 character. I think it's going to be 8 character padding. So we're going to split it by 8. Oh, because it's always 4. Yeah, we can just zip it up and then split by 8, right? Because it's hex. So if we do from hex to string, let's do that. So let's write it from hex to string. It should convert a hex string to a normal ASCII string and do from hex to string. We'll do this, right? Must equal to hello. Okay, so we'll do that. Save that, and then we'll go write a test for it. Or go write a function for it. So from hex to binary, let's just do from. So function from hex to string, hex string, it's going to return a string, right? And we're going to do from hex to binary, hex string, and then join by that, right? And then substring every, what is it, 8? What's the definition for substring? Substring. Data we give substring every. Oh, it takes 2 arguments. That's the issue. So I know I'm doing it in the wrong order here. So we want this and 8, and then we'll do substring every. Okay, so that's going to give us back splits a string array. So now we need to take that. So set this as a variable. Do var 8 bit 8-bit binaries equals this, and close that, and then we'll say 8-bit binaries, and we'll do from binary to string. That. Save that. Let's see if that works. I bet it does. So we have all this complex code, and the fact that we're writing on our tests first means we can think about it and we can reuse chunks of it. So getting very reusable. We have a lot of helper functions at this point. So I got a broken test somewhere. Oh, yeah, this is no good. It's not going to compile our code probably. Oh, yep, but those tests passed. Yep, so we're back to having this working. So now we have a function for, we don't have to do from binary to string. We can do, so we have XOR decrypted from hex to binary, right? And then we don't even need that. We can just do from hex to string now. So from hex to string. This. So hello equals hello. And we'll say we're going to import from hex. We need this getting long. Let's chunk it up here. Maybe not. Maybe we can't chunk it up. From hex to string. Can we break up our, is that something we can do? I think we can. Yeah, it looks like we can. So we've got, let's do that. Let's see if that runs. We've got a lot of imports that we're doing here. Says something's wrong somewhere. Oh, well, we have hello defined. Expecting type array of strings, but got string. From, okay, that's because this should just be hello, right? Hello must equal hello, right? Hello must equal to hello, all right? Yep, syntax. I like that we can just do this must syntax inside of our, hey, our tests are passing. Sweet. Inside of our do block like this. That's nice. Cool. So I'm learning things. Turns out you can write your tests inside of a do block. It's just more data weave. Um, okay. So from hex to string, decrypt hex string, hello must equal to hello. XOR decrypt hex string. Yep. All right. Cool. XOR encrypted hello. We encrypt it with A, and then we decrypt it with A. Let's break this up. Let's move this here into a test. Let's make our tests more reasonable here. So we're going to move this into a test. We're going to say do this, right? And dash, dash, dash. And then we're going to move this here into our test. And that way we can decouple these two. So they're not using the same setup variable, so that if we need to change it for one test, we don't have to break it for the other, but then we can just grab this right here, set it to that there, and give us back hello when we from hex to string the XOR encrypted string, right? Cool. So I think we have everything we need, because what we can do is we can XOR encrypt, or we could take a XOR encrypted string and we can run our candidates against it. So I think we're all set to do this part. So we need to go back to our XOR break, and we're going to start scoring. So we have XOR decrypt string. So here's our hex characters. We're going to reduce, and we can actually import hex characters. We don't need to add them to our test. Sweet. So we have them up here. So we'll just delete that. So we have hex characters, right? Yep, we have them. We've already written them. We don't need to rewrite them again, because whenever you import that library, you just get the hex characters. Okay. Yep. Okay, so now we want to write a test that says it should score every hex character against a hex string in single character XOR 0 must equal to hex characters, right? So we're going to uncomment this test. And hex characters is just the keys of, and we'll do hex characters reduce. Let's set this test up. So do block var scores equals hex characters reduce character ACC equals object, and okay, we're gonna say oh, that's right. ACC plus plus character. Do that for now, right? And then we're gonna say we're gonna delete this, and we're gonna move this into here. And these characters, we can just take this off now. All right. So this is gonna fail. We went to actually build our object in a little bit, but we'll figure it out. We're gonna score here in a little bit. Actually, it might not fail because I don't think we've got our logic implemented in our function yet. Array type, but was object. Okay, so am I expecting an array? Let's equal to hex characters. ACC. Just as a sanity check, I've got an object, and if I plus plus that object with another object, a1, I get a 1. Okay, right. That's right. So I'm reducing over it and building an object, right? Single score x characters 0 must equal to. Okay, so this says I'm probably returning. No, I'm returning an object. Oh, but I didn't return an object here. Did I? Hex characters reduce x ACC plus 0. Hex characters reduce character. This is literally the same. Oh, no, it's not. Must equal to scores. There we go. And then we got to figure out what we want our scores to be. Yeah, this should pass though. Uh-oh. Type number was not present in object. Soon to character. Whoa. What was that? X characters. Reduce. Character. What did I say hex characters were? Keys of hex to binary table. Hex to binary table is I need to wrap this. Okay. probably do need to wrap it. Let's see what we get now. There we go. That fixed the issue. Okay, just needed to wrap that so that it knew to assign it as the key. Okay, so let's think about how we're going to score a particular. So here's where we're going to do our scoring, right? Right here. So we need to write a score function. So function score character, right? So we're going to do so hex string. It's going to be a single character string, but we're going to return back a number, right? And we're going to say so the first thing we're going to do, so let's do this in a do block. Var converted hex string equals from hex to string hex string, right? So we need that from hex to string. And then we're going to say case converted string, converted hex string, right? No, match converted hex string. So we're going to do matches on it. Match converted hex string case what is the syntax for that? Data weave pattern matching. Oh, it's the match comes after, right? Match. So do that. Okay. Match. So we can do this. If it is one of these characters right here, right? Case character. Let's see, what's our pattern matching syntax here? Case condition, routing expression. So case character matches that, right? That. Then we're going to say 2, right? Case character matches that. Then we'll return 2. Else 0 for now. So does that work? Why is it not like there? All right, let's start over here. Something's wrong. So we've got this expecting type number, but got string. Okay, so string match this, right? This. We'll just do this. Turns 1, else turns 0. Okay. We want case. Yep. Okay. So that's valid syntax. All right. So now we want case character matches a. Yep. That square brackets. Then we want 1. Okay. We'll even do this. Case character matches, and we're going to give it 2 for um, if it's, so it's 2 of the same of, oh wait, well, no, we're only doing 1 character, so we can't do 2, right? So we'll just do this, right? So we're going to do that, right? All right. So we're scoring a character based on, so hex characters reduce character, so binary candidates. Yeah, no, that's not going to work because we need to, this right here needs to be how many times the binary candidates shows up, right? So hex characters, single character XOR scores. So we need to do our XOR, and then score the character, right? So yeah, we can actually score the whole thing, right? Yeah, what's what we'll do. So we got hex characters. We're going to check the hex character and we're going to give it a score for, yeah. Yeah, let's do that. So we're going to do that. So we need to, in here, we need to add some logic. So we have binary characters, binary candidates from hex to binary, hex characters, reduce character, character. Actually, we can just do from hex to string. So we can just do hex characters. We don't even need, oh, yeah, of course. From hex to binary, binary candidates. Oops, didn't mean to do that. There we go. So here we are going to iterate over hex characters and score each hex character by how many times it shows up in, by how many points we get using it in our key. So um, So when we score a particular character, we're going to say this hex string and so we want hex character and binary candidates, right, of strings, right? And then we're going to say for each for that hex character, we're going to score it against the binary candidates. So we want to take the binary candidates and do binary to hex, right? And then from hex, do hex to string. And then for each string character, assign it a score. Okay, so let's do some variables here. So we're going to have, we don't want this right now. We want a variable called hex candidates equals binary candidates from hex from binary to hex binary candidates from hex to binary. We don't actually need to do that because we already have. So can we just pass in by hex candidates? We don't actually need to convert them to binary here. So let's just do this. So I'm just going to put a placeholder here. Candidates. I think we need this. Okay. And then hex characters. Let's just put an empty string here for now. Let's do this. Oh, because that's not a number. That's why. Okay, so single character XOR scores is hex characters reduce over them. For each character, we're going to compare that character against the hex string. So we have hex characters and hex string, right? Oh, perfect. We can, so we want to XOR that, right? So for each character, we will do a single XOR. So fix XOR. No, we want to, let me look at my XOR. So it needs to be the same string length. So I want to XOR decrypt hex string. Fixed XOR that. Yep. XOR decrypt hex string. Okay. we'll just pass this to a function. So for now, we're just doing this. So character. Take that off for now. And for XOR decrypt hex string, I need a hex string and a candidate character, right? So my hex string is going to be hex string that. There we go. Expecting type object but got string. That's fine. We'll fix that in a minute. Okay, so I got, cool. So we're XOR decrypting the hex string and getting back our thing. And now we want to score that character, right? So XOR decrypt hex string is going to give us back a fixed, so it's going to give us back a hex string, and then from there we can do from hex to string this, right? And pass that to um, actually we want that still be a hex, right? So then we can just pass that to score character. And the second argument is going to be this is going to be string. The second argument will be hex string. I think I've got my, there we go. I think we got that wrong. Expecting object but got number. Okay, so now we're getting back numbers, right? So now we can say character this and ACC plus plus this. And we need to refactor all of this because it's a mess. And this is auto-coursing type from key to string. That's fine. Character. Yeah, well, we can fix that easy enough. We can just do the coercion up here. Hex characters, keys of hex characters, map as string. Right? Auto-coursing type from key to string. Keys of map $sign as string. Is that right now? Bum, bum, bum. So scope type coerced. Okay. I could just do this. String. I don't know why it's doing that. We'll just leave it alone. Okay. Don't think it matters right now for what we're trying to do. So interestingly enough, we're going to get back. Everything's going to score 1 right now, regardless of what you send. Right? Let's do that. See what we get. So it's actually going to be the opposite. Everything is going to instead of being a 0 is going to be a 1. Actually, come to think of it, every 2 hex characters is a single string character, right? Well, we can't score an individual hex character. We're going to have to break that up into chunks of 2 and score that, right? Ugh, that's a mess. We'll see in a little bit. What's going on in my debug console? Test results terminal. What's going on here? Why are you taking so long? It's telling me I have an error. The only error I see is this auto correction. Whatever. May have just been going too long. Okay. We got to break this up. So hex characters. I'm going to do this. Let's stop our. Can we stop our test? Something's going on with our tests, but we'll figure it out later. Okay, so we're going to do this. Do var string character equals character as a string. I think it's time to restart Visual Studio Code. I think that's a good stopping point for us. We've been going for a while. So I think I'm going to call it there. And I got a meeting in about 45 minutes I need to get ready for anyway. So we're going to call it.